Hello friends, welcome to Tech Tutor with Viji. Today we are doing 20 data structure previous year questions from UGC NET. These questions came in real exam, so pay full attention. Let us start with question 1. Question 1 from UGC NET 2021 June. It's a concept of arrays. The question is, what is the time complexity of accessing an element in an array by index? Option A order of n, option B order of log n, option C order of 1, option D order of n square. For example, if I say give me the element at index 3, how fast does this happen? Please pause the video now and try all the four options. Think for 30 seconds. The correct option is option C order of 1. Let me explain why in a very simple way. Friends, think of an array like a row of boxes in a shelf. Box 0, box 1, box 2, box 3. Each box is at a fixed position. Now, if I say, give me box 3, do I need to open box 0, box 1, box 2 first? No, I can directly jump to box 3 because I know its exact address. This is called direct address. The computer calculates the address using a simple formula: base address plus index multiplied by size of each element. This calculation always takes the same time, whether the array has 10 elements or 10 million elements. That is why the time complexity is order of 1. It is a constant time. Compare this with a linked list. In a linked list, to go to the position 3, you must go through position 0, position 1, position 2, and position 3. That would be order of n, but array direct jump order of 1. The memory trick is array index equals direct address. It is always order of 1. Great. Question 1 is done. Now let us move to question 2. Question 2 is from UGC NET 2022. It is from the concept of stack. It's very simple concept and it is an important concept. Which principle does the stack follow? Option A FIFO, option B LIFO, option C LILO, option D FILO. Pass the video and try the answer. The answer is option B LIFO. Lost in first out. Let me explain with real life example. First, imagine a stack of plates in your kitchen. You put first plate, then second plate on the top and third plate on the top. Now, when you want to take a plate, which one do you take? You can able to take plate 3 only because it is in the top, which you placed in the last. You cannot take the plate, first plate, it is in the bottom. This is the exactly how the stack works. The last element you put in the first element that comes out. That is why we call LIFO. That means last in first out. That means last in first out. Stack has two main operation. One is push, another one is pop. Push means adding an element on the top. Pop means removing the element from the top. Both happen at the top only. Now, some students get confused with option C and D, LILO and FILO. But LILO and FILO are not standard terms in data structure. They are just a trap option in your exam. Always remember stack equals LIFO. Lost in first out, lost plate placed in first plate taken. Great. Question 2 is done. Now let us move on question 3. Question 3 is from UGC NET 2023 June. It is from the concept of queue. Which principle does a queue follow? Option A LIFO, option B FIFO, option C random, option D priority. Pause the video and try the answer. Answer is option B FIFO, first in first out. Let me give you the easiest real time example. Friends, think about standing in a queue at a bus stop or a bank. The person who comes first stands at the front. When the bus comes or the counter opens, who gets served first? The person who came first, the one standing at the front. This is exactly queue. The first element that goes in is the first element that comes out. That is first in, first out. In a queue, we insert at the rear end, that is in the back of the line, and we delete from the front end, that is from the front of the line. So the first person to join the queue is always the first to leave. Compare with stack is LIFO, queue is FIFO. Remember this difference, it is asked in every year. Memory trick. Queue is like a queue at a ticket counter. First person in a line gets served first. Great. Question 3 is done. Now let us move on. Question number 4. Question number 4 is from UGC NET 2021 December. It is from the concept of linked list. Time complexity questions. If I want to insert a new node at the beginning of the linked list, how long does it take? There is 4 options given. Pause the video and try the answer. Correct option is option C, order of 1. It's just like a array access. This is also constant time. Let me show how. Friends, first let me quickly explain what is a linked list. It is a chain of nodes. Each node has two paths. Each node has two paths. It's a node. Each node has two paths. One is data part, another one is pointer part. The pointer part points to the next node. The next node also have the same division, data and pointer. These two points to next node. This is the linked list. Now to insert at the beginning, what do we do? Just two simple steps. Step 1, create a new node. Create a new node. Step 2. Make the new node points to the current head node. This is the current head node points to the new node. Step 3. Update the head to point to the new node. This is the linked list. See how many steps did we did? Just two pointer changes. So we did not need to go through the entire list. It does not matter if the list has 10 nodes or 10,000 nodes. We always do just two steps. So the time of constant is order of 1. Compare this with inserting at the end. For that, we need to travel the entire list to reach the last node. That would be order of n. But the beginning, order of 1. Memory trick, insert at the beginning of the linked list. Just update the head pointer as order of 1. Great. Question 4 is done. Now let us move to question 5. Question 5 is from UGC NET December 2022. It's a concept of binary search tree. What is the time complexity of searching in a balanced binary search tree with n nodes? Four options are given. Pause the video and try the answer. The answer is option C, order of log n. This is one of the most important time complexity to remember. Let me explain with a simple example. Friends, let me first explain BST in simple words. In a binary search tree, every node follows one rule. Left child is, this is the root node, this is right child, this is left child. Left child is smaller than the parent, right child is larger than the parent. This rule applies to every node in the whole tree. Now, when we are search for a value, say we want 45. We want to find 45 in a tree. In this tree, we need to find 45. We start at the root node. If 45 is less than the root, we go to left. We ignore the entire right side. If 45 is greater than the root, we go right side. We ignore entire left side. Every single step we are eliminating half of the remaining tree. This is exactly like a binary search on an array. We keep cutting problem into half. Starting with n nodes, next step n by 2, next step n by 4, next step n by 8. How many steps until we reach one node? This is log n. But wait, this only work for balanced tree if the tree is unbalanced or skewed like this. Unbalanced or skewed like all nodes are at one side. It becomes like a linked list and search becomes here order of n. Binary search tree only order of log n. In a skewed or unbalanced tree, it becomes order of n. That is why the question say balanced binary search tree. Here the memory trick is balanced binary search tree search order of log n because we cut the tree in half at each step. This is important. Great. Question 5 is done. Now let us move on question number 2. Question number 6. Question number 6 is from UGC NET 2023 December. It is from the concept of shorting. What is the best case time complexity of bubble shot? Four options are given. Pause the video and try the answer. Correct option is option C, order of n. Friends, let me explain how bubble shot works. We compare two adjacent elements. If the first is bigger than the second, we compare adjacent element. For example, 15, 12. We are comparing these two adjacent element. If the first element is bigger than the second, so 15 is bigger than 12, we swap them like 12 comma 15. We are swapping first element and the second element because first element is bigger than the second one. We keep doing this pass after pass. This is one pass. Next we are doing next pass like this. The largest element bubbles up to the end after each pass. This is called the bubble shot. Now the worst case is when the array is completely in reverse order. We need maximum comparison and swaps, order of n squared. But best case is when the array is already shorted. Here is the small thing. If we add any optimization flag that checks whether any swap happened in the past, or if no swap happened, that means the array is already shorted. We can stop immediately after just one pass. One pass means we go through all n elements once, that is order of n. The best case is order of n. Important to remember these three cases. Worst case is order of n square, average case is order of n square, best case is order of 1 because the array is already shorted in only one pass. This is most important for exam point. The memory trick is bubble short. The best case is order of n when it is already shorted. Worst case is order of n always. Order of n square always worst cases. That's it about question number 6. Now let us move to question number 7. Question number 7 from UGC NET June 2020. It is from the concept of hashing. Hashing is very important topic. What is the average time complexity of search in a hash table? Four options are given. Pause the video and try the answer, friends. Correct answer is option D, order of 1. Friends, imagine you have 1,000 students in a class and their records are stored. If I ask you to find the student with the roll number 456, there is 1,000 students in a class. I store their records. Now I need to find 456th roll number record. How do you find it quickly? With the hash table. We find it quickly by using hash table, using the hash function. The function takes the key as this roll number takes as a key and calculate an index directly, like hash 456. has 456 equal to 56. So the student 456th record is stored in the index 56. When we searching, same hash function gives index 56 directly. We jump straightly to this position and find the record. No need to check other records. That is why average search time is order of 1. Average search time is order of 1. We compute the index in only one step. We directly go there. But wait, what is the worst case? Sometimes two different keys can produce the same index. For example, has 456 also 56. If I need to find the record 256 also, the hash function is 56. Now the key is same for both the records. So here is the confusion. So here the collision will occur. The collision will occur. When many collision happen, search becomes order of n. If there is no collision, order of 1. If collision will happen, then it is order of n. It is the worst case. So that is why question says average case. In the average case with a good hash function search in order of 1, the worst case done in order of n, but it is rare. Here the memory trick is hash table search order of 1 average. That means direct key to the index mapping like our phone directory. Great. Question number 7 done. Now let us move to question 8. Question 8 from UGC NET June 2021. It is the concept of binary trees. It's a formula question. What is the maximum number of nodes in a binary tree of height h? Four options are given. Pass and try the answer. The correct option is option C, 2 power h plus 1 minus 1. Here, let me show how the formula works by drawing the tree level by level. Height 0 means just the root. Height 0 means the tree has just the root. Only one node. Next, level 1 has maximum 2 nodes. Level 1 have maximum 2 nodes. That means 2 to the power 1. That means 2 nodes. Level 2 means 4 nodes. That means 2 to the power 2. Next level 3 means 2 to the power 3. That means 8 node. That means 8 nodes. For a tree of height h, we have levels from 0 to h. Total maximum node up to h. The geometric series 1 plus 2 plus 4 plus 8 up to h. So for these formulas geometric series we have 2 power h plus 1 minus 1. So this is the answer 2 power h plus 1 minus 1. Maximum node in a binary tree of a height h equal to 2 power h plus 1 minus 1. This is a geometric series sum. It's a full binary tree. Every level is completely filled. The memory trick is maximum node in a binary tree of height h is 2 power h plus 1 minus 1. Just double level by level and sum. Great. Question number 8 is done. Now let us move on question number 9. Question number 9 is from UGC NET 2022 June. It's from stack. Applications of a stack. Which data structure is best for evaluating the postfix expression? That means arithmetic postfix expression. Four options are given. Pause the video and try the answer. Correct answer is option B, stack. We always remember to evaluating the postfix expression, we need only stack. Push and pop operation is in the stack, so stack is easy to evaluate the postfix expression. So we all know this. Application of a stack is a postfix expression. The memory trick is for expression evaluation, we need stack. We have push and pop operators. So question number 9 is done. Next we move on question number 10. Question number 10 is from UGC NET 2023 Zoom. It's from the concept of shorting. Which shorting algorithm has the best worst case time complexity? Four options are given. Pause the video and try the answer. Correct answer is option C, merge sort. Friends, let me quickly compare all four algorithms in their worst case. Bubble sort, order of n square, selection sort, order of n square, insertion sort, order of n square, merge sort, order of n log n. This is the best among the four. Its bubble sort is very slow for large data set. Selection sort is slow, always does the same number of comparison. Insertion sort slow when array is in reverse order. Merge sort is only best among all the four. Why merge sort always order of n log n means it uses the divide and conquer method. So only we say it's a best. Divide and conquer method, it split the array into two offs. This is array, it split the array into two offs, sorts each off separately, this off separately, this off separately. Then merge them. After the result, we will merge them. No matter what order the data is in, shorted or reversed or random, it always does the same number of steps. The split all log n levels, and at each level we do n work. So n times log n equal to n log n. This consistency is why merge sort is preferred for large data sets, while bubble, insertion and selection sort can be fast in best case. This worst case is much worse. Here the memory trick is merge sort always order of log n in all cases. Best worst case guarantee among basic sorting algorithms. Great, question number 10 is done. Now let us move on question number 11. Sorry. Question number 11 is from UGC NET 2021 December. It's from the concept of queue. Which data structure is used in breadth first search of a graph? Four options are given. Pause the video and try the answer. Correct answer is option B, Q. Friends, let me explain BFS in simple words first. BFS, visit a graph level by level. For example, say graph. It's a graph. This is level 1, level 2, level 3. BFS complete the level 1 first. After that it complete level 2. After that it complete level 3. So BFS complete the graph level by level. Why does BFS needs a queue? Because BFS visit the node in the order that were discovered. The first node we discover should be the first node we explore, and that is exactly FIFO, first in first out, which is what a queue does. Think of this like you visit a node A first, you discover A, then neighbor B and C, you add B and C to the queue. Now you explore B first. It was added first. You discover B's neighbor D and E, add them to Q. Now explore C and so on. The queue make sure we process nodes in a right order level by level. Remember queue is level by level, that means BFS, breadth first search. There is another concept, DFS, depth first search. This uses the concept of stack. We also called it as a regression. These are all the keyword to remember. DFS, stack, regression is are all same. BFS, Q. This is one. Don't confuse with DFS with the Q, BFS with the stack. DFS, stack, regression, BFS and Q. The memory trick is BFS Q, FIFO, DFS stack, LIFO. B comes before D, so Q comes before S. Remember this. Great, question number 11 done. Now let us move to question number 12. Sorry. Question number 12 is from UGC NET 2022 December. It is the concept of heap. Simple, but it is an important concept, heap. In a max heap, which element is always at the root? Four options are given. Pause the video and try the answer. Correct answer is option B, largest element. Friends, a heap is a special kind of binary tree. It has two types. One is max heap. Here it is. One is max heap. Another one is min heap. Max heap, every parent node must be greater than or equal to the child. In min heap, every parent node must be smaller than or equal to the children. Heap are used in the priority queues. Heap mostly used in priority queues when you always want quick access to the highest priority element. Always use in heap sort algorithm. Key operations: insert, take order of log n times, find maximum or minimum in order of 1 times because it is always the root. Deleting min and maximum happens in order of n. Order of log n, sorry. Order of log n. Order of log n to insert or deleting maximum or minimum from a heap takes order of log n. To find the maximum and minimum element in heap, it takes order of 1. This is most important. Max heap root maximum, min heap root minimum. This is a minimum. This is a very simple trick. Great. Question number 12 done. Now we move to question number 13. The question number 13 is from UGC NET December 2023. It is the concept of linked list. Which type of linked list allows traversal in both direction? Four options are given. Pause the video and try the answer. Answer is option C, doubly linked list. Singly linked list, circular linked list, doubly linked list. In singly linked list, each node has a data plus next pointer. It access only one direction. Circular linked list. In the circular linked list, last node points back to the first node, like circle. Last node points to the first. This is single linked list, just a line. Last node points to the first one. It's a circular, only one direction. Doubly linked list. In doubly linked list, each node has data plus next pointer plus previous pointer. It has three datas. Here it is data. Here it is previous pointer. Here it is next pointer. This is doubly linked list. Travels in both the direction. Two pointers in doubly linked list allows to travel forward and backward. It will go like this, and also it will come like this, both the direction forward and backward. This is why doubly linked list is used when you need to go in both the direction, like in your browser history where you go back and forward. So in your music playlist where you click next and previous. So doubly linked list, two pointers, two direction, forward and backward. Remember this trick. Great. Question number 13 done. Now let us move to question number 14. Question number 14 is from UGC NET 2021 June. Is from binary tree traversal. In which tree traversal is the root node visited first? It's very easy question. Pause the video and try the answer. Correct answer is option C, pre-order. There are three traversals. There are one is pre-order, one is in-order, one is post-order. Order, it travels from root, left, right. Root first visited, after that left, after that right. Root visited in the middle, left, root, right. In post order, root is visited last. If there is a tree, in pre-order, it visit first root, after that left, right. In order, first it visit left, after that root, after that right. In post order, first visit left, next visit right, after that root. So these are the three types of binary traversals. Here the memory trips is pre means before, in means between, post means after. This is the position of the root. Remember that this is the position of the root. Pre equal to root first, in equal to root in the middle, post means root in the last. This is easy question. Great. Question number 14 done. Now let us move to question number 15. Question number 15 is from UGC NET 2022 June. It's from the searching concept. What is the time complexity of binary search on a shorted array of n elements? Four options are given. Pause the video and try the answer. Correct answer is option D, order of log n. Friends, binary search works only on sorted arrays. This is very important. If array is not sorted, you cannot use binary search. Here is how binary search works. Say we have a sorted array of 16 numbers. 16 numbers. We are searching for a value. Look at the middle element. Is our value is equal to it? If yes, done. If our value is less, we search only the left of. Ignore the right of. If value is more, we search only right of. Ignore the left. Repeat with the remaining of. See what happens. Start with 16 elements. After the first step, 8 elements only remain. After the second step, 4 elements only remain. After the third step, 2 elements remain. After the fourth step, 4 elements only remain. Done in just 4 steps for 16 elements. That means 4 steps for 16 elements. So, log log 2 of 16 equal to 4. So that is order of log n. Compare with linear search, it would check elements one by one up to 16 step for 16 elements, so order of n. But here it checks by splitting the array into 2. Again it's splitting into 2, n by 2, n by 4, like that. So it goes to order of log n times. Binary search is much faster, but remember array must be in sorted order. Remember, for the binary search, array must be in sorted order. This is the fastest search. Binary search is order of log n. Each step halves the search space. Great. Question 15 done. Now let us move on question number 16. Question number 16 is from UGC NET 2023, from the concept of graph. What is the minimum number of edges in a connected graph with n vertices? 4 options are given. Pause the video and try the answer. Correct answer is option B, n minus 1. And when the graph has exactly n minus 1 edges and it is connected, it becomes tree. Let me explain. Friends, a connected graph means there is a path from every vertex to every other vertex. No vertex is isolated. Isolated means separated. Think about it simply. If you have n vertices that all are separate, you have 0 edges and it is not connected. To connect them one by one, each new connection you make require one edge. To connect n vertices into one connected structure, you need n minus 1 edges. For n vertices, we need exactly n minus 1 edges. Let us verify with a simple example. 3 vertex. Minimum edges equal to 3. Minus 1 equal to 2. There is a 3 vertex. There is a 3 vertexes. We say for n vertices, we need n minus 1. For 3 vertexes, 3 minus 1, 2 edges. Here it is 2 edges. So two edges all connected. If you remove even one edge, if you remove this one edge, the graph is unconnected like this. 4 vertices we need minimum 3 edges. 5 vertices we need minimum 4 edges. Now here it is a interesting part. A connected graph with exactly n minus 1 edges and no cycle is called spanning tree. Is called spanning tree or simply a tree. This connect back to what we learned earlier about the trees have exactly n minus 1 edges. If we have more than n minus 1 edges, cycle will form. If we have more than n minus 1 edges, the tree will form a cycle. So if you have less, the graph become incomplete, disconnected. If it is less, the graph is disconnected. If it is more, it forms a cycle. So for a tree with n vertices, always have n minus 1 edges. It's important. Remember this. Memory trick, minimum edges for a connected graph is n minus 1. It becomes a spanning tree. We call it as a spanning tree. Great. Question number. Now let us move on question number 17. Question number 17 is from UGC NET 2021 December. It is from the concept of stack. A stack is implemented using an array of size 5. After we done push 1, push 2, push 3, pop, what is the top element? How the stack will work? This is the question. There is 4 option is given. Pause the video and try. It's very easy question. Answer is option B 2. Here there is a stack of size 5. 1, 2, 3, 4, 5. The stack is completed. Now we are pushing first element, after the pushing second element, after the pushing third element. Now we are pop. Pop means topmost element will be removed. Here the topmost element is 3. So 3 will remove. Now the top element is 2. This is a very easy question. Here is the explanation. Top 1, top 2, top 3. Then we remove the third 3 element. The top must be 2. Pop removes you need to remember the pop removes the top element. Last what we pushed it will be the remove. After popping 3, the top will becomes 2. This is the concept. That's it about the question number 17. Now let us move to question number 18. Question number 18 is from UGC NET 2022 December. It is from the concept of sorting. Which sorting algorithm is based on the divide and conquer strategy? There is 4 option is given. Pass and think about your each option. Answer is option C, quick sort. Friends, let me explain why divide and conquer means. It have three steps. Divide the problem into smaller sub-problem, conquer by solving each sub-problem and combine the result. Divide, solve and combine the result. This means divide. Bubble shot compare the adjacent element. Bubble shot to compare the adjacent elements and swaps. No divide and conquer, just a simple comparison. Order of n square. Order of n square. Insertion shot. Insertion shot take one element at a time and insert in the right position. Here also no divide and conquer is used. Selection shot is also order of n square. Sorry, insertion shot is also order of n square. Selection shot is also order of n square, but it finds the minimum element and places it at the beginning. Here also no divide and conquer method. Bubble shot also no divide and conquer.